For problem number 10 on the Gauss's law homework sheet, it states there are two thin spherical non-conducting shells of radius b and a for b is greater than a. The outer shell carries a charge q and the inner shell a charge negative q. Find the electric field for part A, r is less than or equal to a. Solve for E. So here I wrote the Gauss's law equation. Here's the left-hand side and here's the right-hand side. I drew a little diagram here, so as stated in the problem, A was the inner radius and B was the outer radius. The charge on the outer radius was big Q and the charge on the inner radius was negative 2Q. So for part A, E equals 0 because there's no enclosed charge. So for example, on this picture here, what if R was equal to A? Then there'd be no enclosed charge. So E is 0. For part B, it states that A is less than or equal to R is less than or equal to B. So for this one, I drew the same little picture right here, and I wrote the surface area for the cube, or for the sphere over here, E 4 pi, and then it's r squared, and then I got the difference of the r's, so it's b squared minus a squared equals, on the side, this is the volume of the sphere, so it's 4/3 pi multiplied by b cubed minus a cubed, all multiplied by negative 2q, which is the charge of the inner sphere, all over epsilon naught. So the resulting electric field of that, of part B, is E equals negative 2q over epsilon naught. Part C states that R is greater than B. So again, I drew the same picture. On the left-hand side, I wrote the surface area, which was 4 pi times E times B squared, which is the larger radius. And then on the right-hand side, I wrote 4/3 pi A cubed, in parentheses, negative 2Q plus Q over epsilon naught. So the resulting electric field for part C was negative 2Q plus Q over epsilon naught. Thank you.